Welcome once again to our session for today. So this time we're going to discuss the basic formulas used in integral calculus. So first we have this integral of a times dx. This is equal to a times x plus the constant of integration. So take note that our a here is any constant. A is any constant. It can be a positive or a negative number. It's a fraction. It's a number that is in terms of square root or in radicals or whatever. No? And we have another formula. The other one is the power formula, which is the integral of x to the power n multiplied by dx. This is equal to x to the n plus 1 divided by n plus 1, then plus the constant of integration, where our n here should not be equal to negative 1. So that's the condition when we use this formula. Okay? Is it clear? So for example, if you are given, say, we have here examples. So number 1, if you are given integral, if you're asked to evaluate this integral of dx, so this is just equal to, so we know that this symbol class, integral, this is just the inverse, no, of the differentiation. So it's just like you have a differential of x and you integrate that one, so we'll just obtain x and then plus the constant of integration. Okay, so another example, if you're given, say, integral of 5 dx, this is equal to, so for this one, by the way, for this one, integral of dx, so this is just the same class as so we can use the formula number 1 here. This can be written as integral of 1 times dx, right? Because 1 times dx is just dx. So using this formula, this one, so we have equal to 1 times our a here is equal to 1, so a times x, so meaning 1 times x, then plus c, where 1 times x is just x, so x plus c. So this is our answer. Similarly to this one, number 2, so this is just the same as following this one, the first formula. So we can write this as 5. You can isolate in similar way that you can also put one outside this integral sign. So we have 5 times integral of dx. So take note, class, the integral of dx is just x. So you can write this in this manner or just follow this. Okay, so this is 5 times the integral of dx, which is x, then plus c. Okay, so another example, if you're given, say, integral of 3 divided by 4 dx, so this is equal to, so using again this formula, so the constant, to make it easier, no, you have 3 divided by 4, then isolate this, then integral of dx. And always take note, class, that integral of dx is just x. So integral of dx is x, then you have here the constant 3/4, so multiply this by 3/4, so you have 3/4 x, then plus c. Okay? Another example. So these are the answers. So another example here, we have example number 4. Integral of 0.25 dx. So this is just 0.25 x plus c. Or if you're given integral of the square root of 5 times dx, so this is just equal to square root of 5 times integral of dx is x plus c. Okay? Now, if you're given, say, integral of x times dx, so what is our answer here? So in this case, class, what do you think? So we will make use of formula number 2. So our n here, x to the n, understood to be 1. So using the formula, you have x to the power n, if we have this power, no? This is in this form, x to the n dx. X to the n dx, it follows this form. Alright, so we have to make use of this formula. So x to the n plus 1, where our n in this given is equal to 1. So x to the power n plus 1 divided by n plus 1. So therefore, this is x to the power 1. Our n is 1, then plus 1, then divided by n is 1, then plus 1, plus c, which is equal to x to the power 2 divided by 2 plus c, or equal to 1/2 x squared plus c. Okay? Another example. So number 6. So number 6, sorry. This is number 7 example already. So number 7, if you're given integral of x to the third power, or x cubed dx. So using the formula, so our n here is equal to 3, n is equal to 3. So the formula is integral of x to the n dx is equal to x to the n plus 1 divided by n plus 1 plus c. Okay, so using that formula, so we have x to the 3 plus 1 divided by 3 plus 1 plus c, or this is equal to x to the 4th divided by 4 plus c. Or you can write this as 1/4 x to the 4th plus c. So number 8, you have, for example, integral of x to the power 3/2 dx. So this is equal to, again using this formula, the power formula, so we have x to the power 3/2 plus 1. So this is 3/2. X to the power 3 over 2 plus 1, then 3 over 2 plus 1, then plus c. Alright, which is equivalent to, what is 3/2 plus 1? So 3 over 2 plus 1, find LCD. LCD is 2, 2 divided by 2 equals 1 times 3, you have 3, then plus, this 1 is understood over 1, so 2 divided by 1 is 2, 2 times 1 is 2, so we have 5 over 2. So therefore this is x to the power 5 over 2 divided by 5 over 2 plus c, where this the rule in division of fraction, you just invert the divisor and proceed to multiplication. Okay, so for this part, so you have 2 over 5. Now you just invert this, then proceed to multiplication, times x to the power 5 over 2, then plus c. Okay, then another example, number 9. You have integral of x to the power 1.4 dx. So again, using the power formula, so we have x to the power 1.4 plus 1 divided by 1.4 plus 1 plus c, which is equal to x to the power 2.4 divided by 2.4 plus c, or simply 1 over 2.4 times x to the power 2.4 plus c. Then example number 10, we have integral of x raised to the power square root of 5 dx. So this is equal to x to the power square root of 5 plus 1 divided by square root of 5 plus 1 plus c, or equal to, you may opt to take the square root of 5, then you plus 1. It's up to you. Or this can be written as 1 over square root of 5 plus 1 times x to the power square root of 5 plus 1, then plus c. Or this is equivalent to when you take what is the square root of 5. So take the value of square root of 5 and then you may put your final answer here. Okay, so I think that's all, and we'll have another example next time. See you in our next video. Thank you very much. Bye.